Okay, so now I'm proceeding on to access networks as I've said in the previous video. Access networks are also commonly known as last mile networks. And the reason behind that is because they're essentially the last or the final segment in the internet architecture. Remember, we're looking at the internet architecture. So they're the final segment in the internet architecture which connects end users, and those users can be individuals, homes, businesses or offices, government institutions and so on, whatever, as well as IoT devices, connecting them to the broader internet. Um, and that broader internet is the backbone networks that I've referred to in the past, right? And they connect to the end users to the broader internet via an ISP. So now we're going to look at these access networks, right? So last mile, the reason why they also referred as last mile lies in the fact that it refers to the connection or the connection from the nearest regional network to the customer premises, or the nearest network node, which would be the regional network in this case, which is the closest to the customer premises. Now, these access networks are critical, and that lies in the fact that they directly determine things like speed, reliability, as well as connectivity to, or they affect um, internet user experience. Um, So we're going to be looking at those internet or access networks technologies, right? Because they affect speed, they affect reliability as well as things like latency. As remember, we looked at latency in the past. All those things, they affect user or internet user experience, right? So these access technologies or access network technologies, there's quite a number of them, and all of them they use physical media as well as wireless technologies in order to deliver connectivity, right? And the first one would be fiber to the home, right? And I've mentioned that when I spoke about fiber broadband technology, and one of the fiber connections that you have is fiber to the home, amongst fiber to the building, fiber to the premises, as well as fiber to the curb, but also focus on fiber to the home. Now, fiber to the home is fiber optic cables that actually essentially extend directly to the customer premises, and have certain features, or they are known for certain things like speed or high data rate or very high bandwidth, and that bandwidth typically varies between 100 Mbps to several, uh, even more than 10 Gbps or 10 gigabits per second, right? So they have a very high bandwidth, have low latency as well, very reliable as well as scalable, right? And they typically have certain components like remember the modems that I talked about. I think it was a video on modems, routers, as well as switches, right? And one of the modems, or the types of modems that you have, is fiber optical network terminal, right? So these fiber optic cable that extend directly to the customer premises actually have or they use optical network terminal, which is at the home, as well as the fiber distribution hub that is located outside. So that would be the first access network which delivers connectivity. The second one is and I've already looked at all these technologies in the past. It's just that in the past I've referred to them or called them broadband technologies or broadband networks, and now actually access networks, right? And we're going to continue to refer to them as access networks. They're the same thing, same synonyms, right? So the second one is actually DSL, right? And I've noticed whenever I say DSL, the captions, or what do you call, the subtitles, they're written as DSLR, but I'm going to try to say it in the correct way, which is DSL, or the digital subscriber line. Now, digital subscriber line are known for using existing copper telephone lines. That's what they're known for in order to deliver or provide internet access. And depending on the type of DSL, right? You remember the different types: ADSL or asymmetric DSL. There is very high bit rate DSL as well as symmetric um, DSL. Now the speeds vary depending on the type of DSL technology it is, right? So for remember that for ADSL, yeah, the speed would vary between somewhere between 1 to up to 24 Mbps. But VDSL or very high bit rate DSL actually has higher speeds, which would range somewhere between 25 Mbps to 100 Mbps, right? So those are the typical speed, right? And DSL is also known for using different frequencies in the copper telephone line, right? Which are not used for voice services, so that phone calls will always remain active. They will not be interfered with, right? Remember that I've said that DSL or copper telephone lines, they actually use these different frequencies in the copper in the copper in the copper cable, right? The higher frequency bands as well as lower frequency bands. And there's a splitter which separates the two frequencies, the lower frequencies from the higher frequencies, right? And DSL uses the higher frequencies for internet data, not the voice services which use low frequencies, right? So the good news about DSL is that it's quite affordable, and um, it uses or it leverages existing telephone infrastructure. That's what makes it affordable as well. But the bad thing about DSL is that the speeds or the bandwidth or the data rate tend to decrease as you move further away from uh, the telephone exchange or the ISP, right? So that would be the second access network or broadband network. But from now onwards, I'm going to refer to them as access networks, right? And the third one is actually cable internet, right? If you looked at cable internet before, cable internet, uses your coaxial cable TV or TV cable networks in order to provide broadband access, right? And has typical speeds or typical features that you would find, right? And then speeds that vary from 10 Mbps all the way to uh, 1 gigabit per second or 1 Gbps, but it depends on the type of DOCSIS system or DOCSIS standard that is used in order to provide internet access, right? Now, cable internet is there's a shared bandwidth among neighborhood users. It's widely available in urban areas. That's one of the things that makes it particularly good, because it's highly available in urban areas, as well as it is actually faster than DSL, digital subscriber line. But the bad thing about um, cable internet is that the the speed or the data rate or the bandwidth or the network capacity actually gets affected, because especially around peak usage times, because the neighborhood users have to share the total available capacity or the total available bandwidth, right? So that's cable internet, or the third type of access network that uh, that connects end users to the broader internet via an ISP. And then there's fixed wireless access. Spoken about fixed wireless access. This thing should be familiar by now, right? And this all these videos are based on all these broadband technologies or the access networks that I'm talking about, to understand the internet, and as well as the underlying broadband technologies or the technologies which provide internet access, right? So the next one is fixed wireless access, or FWA. Now FWA uses radio waves to provide internet uses radio waves that are transmitted from a fixed tower, and those radio waves, transmit from a fixed tower to a receiver antenna that is installed at the user or customer premises, right? And typical speed of FWA or fixed wireless access is similar to cable internet, would vary between 10 Mbps to somewhere between let's say 1 Gbps, right? But it depends on the type of FWA technology that is used. Okay, now the good thing about FWA um, or fixed wireless access is that it is first of all, it's known to be very useful in rural areas or underserved areas, right? So it provides coverage in those areas. But the bad thing about FWA is that it is prone to um, this issue of that it requires line of sight, right? Which means the user or the customer needs to be closer to that wireless transmitter or the tower, understand? And also the signals would be affected by the weather. That's another bad thing about FWA, fixed wireless access. And then there is mobile broadband, your 5G, your 4G, and so on. Those mobile broadband generations, all of them, whether it's 3G or 4G or 5G, but I'm going to focus on 4G and 5G. They actually use, as I've said in the past, that they use cellular networks or regional cellular networks in order to provide internet or wireless internet. And depending on whether it's 4G or it's 5G, they have typical speed. Let's say when you talk about 4G, we would have in a bandwidth or data rates that range between, let's say, 10 Mbps up to 100 Mbps, right? That's the typical bandwidth for 4G, but 5G is actually way faster, or it has a very high bandwidth, and that's similar to um, fiber internet or fiber to the home, right? With speeds that vary between 100 Mbps to several Gbps or gigabits per second. So that's mobile broadband, right? And mobile broadband, 4G and 5G is actually known for having low latency as well as high mobility. That means you can access, as we all know, we can access it anywhere as long as it's within coverage. So it has high mobility as well. It supports IoT devices, supports smartphones as well as mobile hotspots. Mobile hotspot, they use 5G, 4G. Smartphones use, it's commonly known, they use 4G and 5G as well as IoT devices. They use 4G and 5G. The good thing about mobile broadband is the fact that it's very portable, can use it anywhere, and it has wide coverage covering the entire country or an entire country and several regions as well. So it's it has a huge coverage, and it supports multiple devices, an increasing number of internet users, devices, as well as internet traffic, right? But the bad thing about mobile broadband, 4G or 5G, whether it's 4G or 5G, is that it is signal dependent, and that simply means that signal strength would vary by depending on the location. And the other thing is what's this? Um, the network congestion. The fact that during peak usage times, the signal strength actually gets affected because there's more traffic flowing through the network, so it suffers from, or the signal suffers from network congestion. So those are the access networks. There are many others, but I'll just um, refer you to those that I've mentioned, I've talked about now. Then there's something called customer premises equipment, right? Um, Now, customer premises equipment is the hardware that is located or is installed at at the customer's premises in order to enable internet connectivity. Now, there is several components that I've covered in the past: modems, there's routers, and hybrid devices connecting uh, modems as well as routers into one unit. So you know that a modem is there to connect ISP signals. Those signals would be DSL signals, cable signals, fiber signals, as well as wireless signals. You know that cable uses radio frequency signals, fiber uses light signals, DSL uses analog signals, as well as wireless uses radio wave signals. So all those are ISP signals, and the modem converts. Remember, modem stands for modulator demodulator device, that converts these transmission, these signals that I've just mentioned, into digital signals. So it converts all these ISP signals into internet data for devices that can be used for devices. And then there are routers, um, part of this customer premises equipment, or CPE. Right now, routers are there to distribute internet connectivity between multiple devices, um, and in order to distribute that connectivity, they use um, Ethernet, or can be Wi-Fi. So it depends on the situation, right? And these routers, they also use network security features, such as firewalls. Spoken about firewalls before. Uh, they use network address translator, as well as quality of service and many other network security features. Right now, hybrid devices connect, or many devices actually combine modems as well as um, routers and Wi-Fi access point into a single unit. Right now, a CPE is important in the fact that it is there to be an interface between the user's local network as well, and the ISP's network, right? And they're there. These types of equipment are there to um, ensure proper signal conversion between ISP signals and the internet data for devices, and also ensure proper connectivity and signal distribution as well, right? So those are customer premises equipment. Now, in order to understand what these access networks are, essentially what we are saying here is that access networks are networks which provide or establish a direct link between the user's local network and the ISP's network, right? So they are like an interface between. Remember, spoken about here. What's this? Local networks. So they're an interface between local networks and regional networks, and besides regional networks, the interface between regional networks and backbone networks. So we have local networks, regional networks, and then backbone networks. So they're an interface that carries all the user traffic. And that user traffic can be web browsing, can be cloud services, anything. Can be videos, can be streaming, can be gaming, all types of traffic. They carry all the traffic to and from the internet, right? Which means that they are there. These access networks are there to connect end users to the internet. Right? Understand? That means delivering internet connectivity to homes, to offices or businesses, to institutions, to rural areas, to uh, name it. Doesn't matter. All the end users of the internet, they're there to connect these users through ISPs, and they're also there to uh, I forgot this other point that I wanted to make, but I'll remember it. Now, I have to mention why they are important, or the significance of these these access networks, and that lies in the fact that they have direct user experience, which means they determine speed. As I've said, they determine latency, they determine reliability as well of internet experience for users, right? That affect various activities like cloud computing, financial services, online banking, you name it, whatsoever, right? And they also are important for digital inclusion, including or bringing connectivity to businesses, to homes, to individuals, to rural areas, to government, to schools, you name it, institutions worldwide, right? So they're important for digital inclusion, they're critical for digital inclusion. as well as supporting modern applications, just like I've mentioned, mobile gaming or online gaming, you name it, video conferencing, cloud computing, all these digital services or modern applications, or even IoT devices as well. All of them, they're supported by these access networks, and they will be mentioned throughout in the upcoming videos, right? So that's how they're important. Um, since I have to cut it here. On the next one, I'll I- I'll just try um, to highlight the other roles of access networks, because I wanted to bring in to for you to understand what the various roles besides connecting uh, end users to the ISP. Oh yes, I just remembered, right? They You remember the equipment that just mentioned, the customer premises equipment. They're there to provide necessary equipment in order to connect those end users to the ISP, and that necessary equipment includes things like modems. It includes routers, as well as this customer premises equipment in order to convert these ISP signals into internet data for users, and also supporting high performance for for these networks. That includes like ensuring very high bandwidth, right? As I've mentioned, the various speeds of the access technologies, the ASL has its own speed, cable has its own speed, fiber to the home has its own speed, mobile broadband has its own speed. So they're there to ensure sufficient bandwidth as well as low latency. Latency that is typically, low latency, or the low latency that is preferred is latency that ranges between 1 and 10 milliseconds, right? As well as there to ensure reliable connection for high performance. Thank you. See you next time. And I'll be talking about data centers as well as internet exchange points, or IXPs. See you next time. Thank you.